Hello! Welcome to the new installment of Physical Modeling Emporium tutorial series. In this episode, we will be looking at Kaivo. Kaivo is a semi-modular synthesizer combining granular and physical modeling synthesis, developed by Madrona Labs. It showcases the possibilities that come with pushing this synthesis type when it's being placed into the hands of creative developers, as well as creative possibilities that you can utilize in your music. Kaivo is divided into 10 sections: key, output, volume gate, the exciter, 2 resonator types, a sequencer, an LFO, 2 envelopes, and a noise gate. The elements interact with each other in a modular-esque fashion by linking cables into each other. For example, let's take this cable corresponding to pitch information and link it to the pitch of the resonators. That way, each note played will correspond with the respective note put in the piano roll. The key section lets us choose a wide variety of possible tunings outside of the Western 12 equal temperament. Try playing with the glide option. Let's look at the exciter now. If you watched the collision tutorials, you might notice a slight difference. We can hear a sound despite none of the resonators being on. That's because the exciter in Kaivo is sample based, meaning we can choose any sound in existence to work as our exciter. That way, we can explore abstract ideas, like a glockenspiel being played by the ocean waves instead of a mollet. Kaivo offers us a wide variety of samples to choose from, as well as an option to import our own. In Kaivo, our exciter's sample comes with a granulizer. That means not only you can play your guitar with the sound of a dubstep growl, but you can granulize that growl's movement. The rate knob adjusts the size of the grains and the speed at which you will go through them. Lower rate will mean a sound closer to the original sample. If your sample is really long, you can use this knob to choose the exact place that will be playing. Some samples in the library have multiple different sound bands that you can switch between using this knob, resulting in a different sound playing. You can automate switching between those positions using an LFO. That way your exciter will be constantly changing. How fun! The overlap knob will affect the density in which the grains overlap. Low rates will result in a choppy, pointillist soundscape, while high rates will make the soundscape full and droning. Penning makes the sound go left, right, left, right. Ooh, fun! With the possibilities of the exciter explained, let's look at the resonators. Kaivo offers us 2 resonators, one called the resonator and one called the body. Let's examine resonator number 1. This resonator is responsible for melodic instruments. We have 8 resonator types to choose from, divided into 3 groups: strings, chimes, and springs. Each differ in either size or the material it would be made of. First up, we have strings, and 3 possible materials to choose from: a metal string, a nylon string, and a gut string. Moving on to chimes, we have three sizes: a small chime, a medium chime, and a large chime. Lastly, we have springs, a small spring and a large spring. We can adjust our resonator's pitch by octave, while keeping the original tuning. Penning goes woo, left-right. Adjusting the sustain knob will affect the internal damping of the resonator, thus allowing us to create sharp, clicky plucks as well as droning soundscapes. Boosting the brightness will increase the amount of high frequencies in the model. Changing the position contributes to where on the imaginary model we hit the resonator. Bringing it to 0 will bring it closer to the middle. Experiment with the non-linear knob to further affect the model's timbre. You can mix the dry and the wet signals however you please together. If you watched my collision video, you can notice how many of those knobs overlap. This is because the basic resonator model stays the same over different plugins. The second resonator in Kaivo is called
body.
It's useful specifically for percussive noises, but you can add a lot of extra space and texture to the sound if you combine it with the original resonator. Just imagine a xylophone resonating in a metal cube. We are presented with 4 different
Body
types: a large wooden box, a small wooden box, a metal plate, and a frame drum. You are also provided with a visual representation of your drum in a form of an XY axis. You can move the 2 parameters to determine what exact point of the box is being hit. Try adding an LFO to it. That way, the position keeps changing. Just like with the other resonator, you can adjust its pitch, sustain, tone, and non-linear parameters to alter its sound even more. Let's combine the two. Your output section comes with 3 effects: a tilt, which works like a filter; negative values work like a low pass, while positive values work like a high pass. Next, you have a chorus, in 2 modes of varying intensity. Lastly, you have a limiter, which I recommend leaving on because of the unpredictable nature of this synth. Let's look at the LFO next. Kaivo's LFO has a 2D visualizer, showcasing its shape and movement on the XY axis. Let's connect the LFO to the pitch values. You have 7 possible LFO movement shapes to choose from: circle, infinity, square, triangle, Gaussian, nights, rain. You can move the XY axis of your LFO to offset it and change the modulated values. You can further offset the LFO by using the offset knob. Increasing the level knob will make the modulation more severe. The rate knob contributes to the speed of the modulation. Choose a really high value for extreme metallic timbres. Just watch out for your ears. Hehe. Last but not least, let's take a closer look at the sequencer section. Let's link it to our volume first. You can draw up to 16 steps on your sequencer. The higher the step, the bigger value your parameter will be changed by. Let's assign it to resonator's pitch as well. The range knob will affect the severity of maximum modulation. The rate knob affects how fast you move through the steps. The glide knob is for pitch sliding between the notes of the sequencer. The step knob can limit the number of sequencer steps to values between 1 and 16. The offset knob offsets which values on the sequencer are chosen. You can choose a variety of different sequencer shapes, as well as a random setting. I recommend playing with it. With all of that knowledge in mind, let's make a patch. Yummy! You can record your patch into Edison, or whatever other plugin you fancy, and resample it in your project. I recommend adding an amen break. You can't go wrong.
Throw your hands up if you with it.
Thank you for joining me into another installment of our adventure. I'm so proud of you. Tune in next time to find out how you can replicate physical modeling properties in Vital. This was Pearl Lamp, and I'm signing off. Goodbye.